just a couple minutes, but whatever. So you put salt in water, it dissociates. The oxygens surround the Na. The hydrogens are aimed away from it because this water has partial negatives, which is your dipole, so they're attracted to the Na, and then the Cl minus would be over here, and all of the hydrogens. I have trouble drawing this one, especially when I'm going fast. I feel like I do not need to show you guys this, but all these H's are partially positive, and you should know this already. So this is what molecule ion or molecule dipole or ion dipole, this is what it's all about. I'm just using the classic example of salt water. What else do I have here? Alright, so if you were to dissolve salt in water, this attraction here would be fairly strong. Now, the only reason anything ever dissolves in something else is if the attractive forces for the solvent are stronger than the solute. In other words, if Na and Cl would rather be attracted to themselves, they would never dissolve in water. So in other words, this is a pretty strong attractive force. It's temporary, but it's pretty strong. It's strong enough to separate the salt crystal temporarily. So the solute-solute interaction is weaker than the solute-solvent. It'll dissolve. So that's a big role. That plays a big role here with this. I want you to write this down, though. If we were to dissolve, let's say, CaCl2 in, I don't know, let's just say hydrogen fluoride if we had a liquid. So if we had liquid hydrogen fluoride, hydrofluoric acid, and we had solid calcium chloride, if we could get this to dissolve, if this was a solution, this solution here would have stronger forces than here. And the reason for that is what I was talking about earlier with the ionic structure. Ca+2 has a greater magnitude of charge than Na+. So the attraction here with the F minus, right? You have a partial F minus, partial H positive here because of the dipole. So this attraction here would actually be significantly stronger than this one. So I just want you to write that. Put that down, that this is a stronger attractive force than between the Na and the O. And again, the magnitude of charge. Ca+2 has a greater magnitude of charge. It also has a smaller radius. Well, that would be hard to tell, actually, because Na only has 10 left. So that's hard to figure out. I would assume, that is 10, that is 18. So I would still assume this is smaller. But the same deal I was saying earlier. The smaller the charge and the more concentrated it is, the higher the magnitude, the better the attractive force. So we'll talk again more about that in detail after the lab. But so I just wanted to mention that. It was in my notes, so I'm going to tell you. That's it. I basically covered everything else. I went fairly quick. I think the best way to learn a lot of this is take what you heard and wrote and just do homework, do practice problems. That's the best way to apply it instead of just memorizing. But all right. So now I will give you 15 minutes to get your thoughts straight with your partner about the lab. Let's review the types of tests